Hello everyone, welcome back with a new video. Today I came with a new topic which is transmission of light from denser to rarer medium, means about the critical angle. This is one of the most important topic of class 10. So let's start. See, up to this we read when the rays goes from rarer to denser medium, then light bends towards the normal. And when light goes from denser to rarer medium, the speed increases, that's why it bends away from the normal. So today I will discuss about this topic, means when the rays goes from denser to rarer medium at different angles. Okay. So first diagram I have taken here. This is, think about glass, and this is air, denser medium, rarer, optically denser medium, and this is optically rarer medium. So take an angle which is small and the ray is going from denser to rarer. So what will happen? The rays bends away from the normal, but there will be some reflection also. So this is the reflected light, and which will obey the law of reflection, means this angle will be also the I equals to R or R equals to I, that's why I have written here I. And here this R is called the angle of refraction. Now, thus in second case, if we increase the angle, okay, so one thing, when the rays comes from rarer to denser medium, there will be also reflection and refraction also. And here when the light goes from denser to rarer medium, then also refraction and reflection, and when the angle increases, the intensity of light keeps on decreasing. Now see, here I am taking the angle, this is also I, but which is little bit greater than this angle. So what will happen in this case? Now see, again the light will bend more away from the normal because the angle of incidence is more. So this is the ray, this is R, and this will be the I. This is the reflected ray, this is the refracted ray. So again I am taking the third case where I am increasing the angle of incidence. So suppose this is the angle of incidence. Now see, the ray is bending away from the normal, and if we increase the angle, then what will happen? Then this ray will touch to the glass air surface. This is glass, this is air. It will touch, means it will fall or it will touch on that glass air interface. Okay. So one thing also I can say, here the maximum angle of refraction will be 90 degree in that case. So here the angle of when the refracted ray touches the glass air interface. So here R will be 90 degree. This is the maximum angle of refraction. If this angle of refraction cannot be greater than 90 degree. Okay. Now in this case, means at the angle of incidence for which the angle of refraction becomes 90 degree, that angle of incidence at the denser medium, that is called the critical angle. This is, I am writing C. This is glass, this is air. Okay. So again I am telling, the critical angle is the angle of incidence at the denser medium for which the angle of refraction becomes 90 degree. That angle is called the critical angle. Okay. And there will be the reflected ray also. See, in these three cases, the intensity of light, it goes on decreasing. Means in this case, the intensity will be less than these two cases. Okay. So we have seen in the first cases, when the angle of incidence is small, then the ray bends away from the normal. This angle is R, and this is the reflected ray. This angle will also be I. And here R is greater than I. Okay. Now in third cases, at the angle of incidence for which the angle of refraction becomes 90 degree, this R equals to 90 degree, that angle of refraction at the denser medium, this is called the critical angle. There will be reflected ray also. Okay, but what will happen if we increase the angle of incidence? See, if the angle of incidence is greater than critical angle, I greater than C, here there will be no refracted rays. No refracted ray is obtained. Means all the rays will come back to the same medium. And this is denser, this is rarer. Okay, so this rays goes back to the same medium. That phenomenon is called the total internal reflection. This angle will also be I. Okay, so when the angle is greater than critical angle, all the rays goes back to the same medium, means to the denser medium. That angle is called the, not that angle, that phenomenon is called the total and internal reflection. Now come to one important topic, which is the relation between the critical angle and the mu, means refractive index. See, we will take the third cases when the I equals to C, that is R equals to 90 degrees. Okay. Now here the ray is going from, this is glass, this is air. The ray is going from glass to air, means denser to rarer medium. So from here we can write that G mu A equals to sin I by sin R from Snell's law of refraction. So here sin I means which one? Sin I means actually I equals to C. Okay, first you write sin I by sin R. Sin I means we can write sin C divided by C means critical angle. Sin R means sin 90 degree. Sin 90 degree how much? 1. So it will be only sin C. Now see here, this G mu A represents the refractive index of air with respect to glass. But we need the refractive index of glass with respect to air. What is the relation? Now one relation we read, 1 mu 2 equals to 1 mu 2 equals to 1 by 2 mu 1, 1 by 2 mu 1. So here we can write this G mu A equals to 1 by A mu G. So from here we can write A mu G equals to 1 by G mu A, means 1 by sin C, which is 1 by sin C means this is cosec C. So the relation we got, A mu G equals to the cosec C. Next, if we want to find the critical angle for glass and for water, see how do you find? We know the refractive index for glass, it is 1.5, or also we can write 3 by 2. So the relation is A mu G equals to 1 by sin C. So here sin C equals to 1 by 3 by 2, means A mu G equals to 3 by 2. So it will come 2 by 3. Here C equals to sin inverse 2 by 3. So what will be the value? It will come near about 42 degree. Otherwise you can write over here sin 42 degree. The value is 2 by 3. That's why from here C equals to 42 we can write. Otherwise here also you can write. This angle will be 42 degree. Okay. Next one, if we want to find the critical angle for water. See what you know about the refractive index of water. This is 4 by 3 or 1.33 something. Here E mu G equals to, apply the formula. So 1 by sin C equals to 4 by 3. Okay. So sin C equals to 1 by 4 by 3, which is 3 by 4. So C equals to sin inverse 3 by 4. Find the value. This value will come near about 49 degree. Otherwise here also you can write sin 49. So C will be 49. Okay. This is how we can find out the critical angle for glass or critical angle for water. Now give the heading, factors affecting the critical angle. Okay, means on which factor the critical angle depends on. First factor is the wavelength or the color. Okay, now see, briefly I am telling, this is represented by lambda. Okay, so when the lambda decreases, refractive index increases, that we read, because lambda proportional to 1 by mu. Okay, so when lambda means for violet color, as the wavelength is less, for that case the refractive index will be more, means mu v is greater than mu red, that we have read. Because why? Because lambda v is less than lambda r, means lambda red. See, from here we can write that mu proportional to 1 by lambda. So mu equals to 1 by c, 1 by sin c, which is proportional to 1 by lambda. So here we can write that sin c proportional to lambda, means when the lambda increases, critical angle also increases, means critical angle increases with increase in wavelength. So for violet color, the critical angle for violet will be less than critical angle for red. Clear? Because of the lambda. For violet, the lambda is less than red. Now, the second factor is the temperature. See, one thing we know, when the temperature increases, then how the refractive index changes? Tell. When the temperature increases, then refractive index decreases. Why? Refractive index means what about we are telling about the optical density. So when the temperature increases, the distance, means separation between the molecules will increase, so the optical density will decrease. So optical density will decrease means the mu will decrease. Okay, so when the temperature increases, mu decreases. Okay, means that mu is inversely proportional to t. Mu means 1 by sin c, which is inversely proportional to t. From here we can write that sin c proportional to t, means when temperature increases, the critical angle also increases. Okay, what about the total internal reflection that I told by the diagram? The definition I am telling. So when the rays goes from denser to rarer medium, and when the angle is greater than critical angle, then there is no refracted ray obtained. All the rays is reflected back to the same medium. That phenomenon is called the total internal reflection. This angle will also be I. So by definition also we can say, when the rays goes from denser to rarer medium at an angle greater than critical angle, then all the rays goes back or is reflected back to the same medium, means to the denser medium, then this phenomenon is called the total internal reflection. Then what about the condition for this total internal reflection? So first condition will be the ray should go from denser to rarer. Okay. Second condition is the angle of incidence is greater than the critical angle. These are two conditions for which the total internal reflection happens. Here you can ask the question, why will you study the total internal reflection? There is reflection, so you can use the plane mirror also. No, there is a difference. See, the advantage is, in this case, in this phenomena, we get the 100% reflected ray. But in case of plane mirror, we did not get the 100% reflected ray because of some absorption of light. Okay, so by using this phenomena, we can get the 100% reflected ray, by which we can construct, or what is the use of total internal reflection? It is used in the periscope. So many applications are there. Periscope. Next one you can say. Next one also binocular. Next, certain types of camera also are there. So there we can use the total internal reflection, by which we can get the 100% reflected rays. Okay. Now in one diagram I will show the refraction, critical angle and the total internal reflection. So here I took one glass air interface. This is glass, this is air. So in all cases I will take the rays going from glass to air, means denser to rarer medium. First I took this I equals to 0, means when the light falls normally. So it undeviates its path, so R will be 0. Now again, if we increase the angle of incidence, okay, suppose this angle is 30 degree. So the ray is going from denser to rarer, so the ray will bend away from the normal. This angle is R, there will be 30 degree reflected ray also, this angle will be 30 degree. Now by using the Snell's law we can easily find out the value of R. How? See, mu equals to sine I divided by sine R. So mu 1.5 for glass equals to sine 30 divided by sine R. So you can easily find out the value of R from this relation. Now again, if we increase the angle of incidence, then so one angle will come when, see, if we increase the angle of incidence, then R will increase also. So one time will come when the R will be 90 degree. And I have shown one numericals what will be the value for critical angle of the glass, which is the 42 degree. Means when the angle will be 42 degree, then what will happen? When I equals to 42 degree, then see, then refraction angle will be 90 degree. Why? Because what is the definition of critical angle? The angle of incidence at the denser medium for which the angle of refraction is 90 degree, that is called the critical angle. So at critical angle, the angle will also be 90 degree. So the refracted ray will be like this, and there will be reflected ray also. Okay, this angle will also be 42 degree. See, one thing I can say from here. From here also easily we can find out the refractive index of glass. See how? This mu equals to, mu means here the ray is going from glass to air. So G mu A equals to sine I, sine 42 divided by sine 90. See, sine 42, sine 90 means 1. Sine 42 how much? Sine 42 is 2 by 3 I told. So A mu G is 2 by 3. So what will be the G mu A? Sorry, G mu A is 2 by 3. So what will be A mu G? A mu G will be 3 by 2. 3 by 2 means this is 1.5. Okay, understood? And the another case, when the angle of incidence is greater than critical angle, means when I is greater than 42 degree. What will happen? When I is greater than critical angle, then there will be no refracted rays. All the light goes back to the same medium, means to the denser medium. This is the reflected ray, and this phenomena is called the total internal reflection. So the two conditions I told, first one, the rays should go from denser to rarer, and the angle will be greater than critical angle. Okay, here see, all the rays are going from the object, therefore the explanation I took like this. Okay, because the object I have chosen over here. So this is all about the critical angle and total internal reflection. In next class I will come with a new topic, which is the total internal reflection through prism. Okay, thank you.